you have given the set of data and you have to find out the median, and median you know, right, how to take the median. So first you have to sort the data. So if I want to take the median for this data, what you will do, you will first sort the data, right? So it will come the 4, 6, 9, 12, 14, and then what the data is coming in middle, that is the your median, right? But if you add one more data, suppose I add the 17, so if you add the 17, then so now count is even. So in this case of the even, you have to find the two middle one. Now it become the 21 divided by 2, it will be 10.5 is the median, right? This is a way to find out the median, right? So but problem is that this is not the static data, right? That is the stream data, means data is keep coming. So in that way, what you will do, suppose first your data 9 came, so you will keep data in the temporary array or any list. So you keep the data 9, you have to sort it, 9 is against 9 and median is equal to 9, right? Now another data comes 6, when the 6 will come, so 9, 6, you have to sort it, right? When you do the sort it becomes the 6, 9, and now the number is the even. So you have to add 6 plus 9 by 2, right? So it becomes the 15 by 2, it becomes the 7.5. Again the third data come 4, 9, 6, 4, again you will do the sort. After sort it becomes the 4, 6, 9, and median is the 6 here because the number is the odd, so median is the 6, 14, so your temp 4, then 14, again you will sort it, so 4, 6, 9 and 14, and median is the 6, 9, 7.5. See, so in this way if you see that whenever you add the number, when you adding the number in your list, you have to do the sorting, right? So if you do the sorting and you know the complexity of the normal sorting, that complexity is come the n log n, right? And to find out the median, that would be the constant. Why? Because from the position you can get it. So if you see the overall for the sorting is this one and for this one, but this is for the one operation. If you have the n data, n number of data, right, again you add one more data, again you will add one more data, so every time this complexity is there. So if you see the overall complexity, you have the n into n log n, right? And this become the n into n. So if you see the overall, your complexity is coming n square, right? And this is very high bound n square. So if any way we can optimize this solution for the better complexity, yes, we do have the optimization solutions, then let me discuss on that, right? So suppose if this number is given there, right, at a point of time, so 6, 4, 14, 12, 7 and the 5, right? So how you do that? We do after sorting, right? So if you do the sorting, it become the 4, 5, 6, 7, 9, 12 and 14, right? And what is the median here? Median is this 7, right? So if you notice that before the median or the smaller number and after median or the greater number, so we can make one two box 1 and box 2. We keep all the smaller number or before the median number in this box, and we can keep after the median number in this box. If you see in that way, we will keep the 5, 4, 5, 6, 7 here and the 9, 12, 14 here. And keep in one mind, box 1 box 2 size should always equal and smaller the box 1. So if you have the odd number, so extra odd number will become here, right? Now if suppose I have the 18, so 18 will become here. So in the case of the even number, then both have the equal. In the case of the odd, this will have the one number more, right? So take the example of the odd first, right? So we keep this number here. How we will keep that, we will see that, right? We will no need to do any sorting when I will explain the actual code. Just for explaining purpose, you will have the two box and we will keep the number here, right? So after keeping the number here, some system should be there who will take the max of this box. So in this case, this is the max, and we will take the mean of this box. So some system there who will give these informations, right? So now if you see, if size is the different or this number is the odd number, then if odd number means box 1 size not equal to box 2 size, then what is the answer? Answer is the box 1 dot max. If you can see that, this is the box 1, their max is the 7. But in the case of even number, right, when box 1 size equal to box 2 size, suppose example 18, then what we will do? We have to take the box 1 max, means box 1 max plus box 2 mean. Box 2 mean you add and divided by 2. In this case, 7 plus 9 divided by 2, 16 by 2, this is the 8, right? So these things we have to consider. So this is the one rules we have to follow, and second rules, that the box 1 can have greater number than the box 2, means box 2 should be always equal and less than the box 1 number. So you can say that box 2 size either less than box 2 size or equal to box 2 size, means this should never the greater. If you keep two things in this mind, we can find about the answers, right? So in this case I showed you example, but now thing is that what is that box who have this kind of the facility that it will give you the max, and this box who can give you the mean? Here is the concept is the heap. I will explain what is the heap. So this will about the max heap. We use the max heap data structure, and here we will use the min heap data structure. What the max heap does, it will give the maximum of all the data, and min heap will give all minimum data among all the numbers. Okay, so let me show you how this heap works, right? So suppose if you have some data, you take some data, the same data, if you take 4, 5, 6, 7. So when you drop the number 4, so it will make this tree structure. I am saying about the max heap. Then you give the 5. So 5 should become the left, right? But the max heap says parents node always or equal to the child node. So here is this 4 parent, this is a child, so we need the swap. So it will become the 5 and then 4. Now the 6 will come here, left side. But again if you see, this parent is less than the 6, again the swap happen. So this will become the 6, here the 4, here the 5. because swap happened between these two numbers. Now the 7 came, 7 should be come here because this is binary tree. But again, if you check, parents is raised, so we need the swap. If you make the swap, this tree become the 7 will come here, 4 will come here, and 5 will come here. But now if you check, parents is raised 6 and 7, then again swap will be here, so this become the 7, 6, 5, 4. Now you can see that the maximum number is always on top, and to build up this tree, they will take the log n time. And when you take out the maximum, it will take the constant time. So always in the max heap, the parent number has the maximum, and the same way in the min heap, your lowest number is as a root. So that's why it is easy to give always the number. So this is the heap concept you can study more about. So, and there are the three important method is there in the heap. One is the add. When you add, it will add the number and the heapify. I was adding the number, right? Another is that the peak. What the peak will do? Peak will give the root information. So when you, according to this one, if you do the peak, it will give the 7. But they will not delete the 7 from here. But if you do the poll, it will return the 7 also, and it will delete the 7 from here also, and again they will heapify to the same constructions. So after that, what happened? If you remove the 7, it becomes the 6, 5, and the 4. So three methods we have to consider in the heap, right? So if you understand all those things, then it's very easy to make that, right? So let me write the pseudocode, and then we will take the same example and see whether we can getting the median or not. So let us start. So what we do, we make the two box, right? One box and another box. This is your max heap. Now you understand what is the meaning of the max heap? Means the maximum data we can operate here. And this is the min heap. Just you have to keep in mind the three steps. Steps first, always add the element to the max heap first. So when you take the first, put into the max heap. Second step, remove the max element, not the same element. It could be the same, but the max element from the max heap and put into the main heap. As this heap has the only one data, so this is the max data. So what we will do? We will do the poll, right? So I take this data and I keep the 9 here. First step, second step. Third step, maintain the mean heap size that should equal and less than the max heap. Now if you see, the size of max heap is 0 size, and this size is 1. So this is the greater. So we should not so it should not. So you have to maintain the size. So we take this 9 and keep it here. So now this size is 0 and this size is 1. So always this size should be equal and less than 1. So 9 is done. Now the 6. Again the step first, put the 6 here. Remove the max element. Now what is the max element? 9 of 6, 9. Remove the 9 and add into the min heap. Third, check the size. Now we have only 1 here, and here we have the only 1. So no need to maintain, no need to move from here to here, right? Now take the 4, keep the 4 here. First step. Second step, remove the max. What is the max? Between 6 and 4, 6, and keep it here. What is the size now? 1, and size is 2. If you take the size 2, you have to maintain. So we have to always poll, right? When you do the poll, this is the min heap. The minimum will come out. So what is the minimum here? 6. So 6 will come here. When you do the poll from max heap, you will take the maximum. When you do the poll from the min heap, you will take the minimum, right? Okay. Now Take the 14 will come here. Step first we done. Second step, remove the max. What is the max? 14. Keep it here 14. What is the size? 2. What is the size? 2. 1 and 2. No need to change anything. Take the 12. Keep the 12 here. Done first step. Second step, remove the max number. What is the max here? Max is 12. Keep the 12 here. Size 1 and 2. Size 1, 2, 3. Now this is the greater size. We have to do the pole. Take the minimum number. What is the minimum number here? Among the 12, 14, 9. So take the 9 here. Size again become the 2. Right? Now here size is 3. It's okay. Now the 7. Keep the 7 here. First step done. Remove this max element. What is the max? What is the remaining here? 9, 7, 6, 4. What is the max? Max is 9. Keep the 9 here. Check the size. 1, 2, 3. Size is 3. 1, 2, 3. No need to perform anything. Take the 5. First step done. Second, remove the max. What is the max among the 7, 5, 4, 6? 7. Keep the 7 here because 7 is the maximum. Now take the size. 1, 2, 3, 4. Size is the 4. 1, 2, 3. Size is 3. Only 3 is there. Here 1, 2, 3, 4. Size is 4. So we have to balance it. So do the pole. We take the minimum element among the 12, 9, 7, 4. Take the 7. Keep side here. Right? All the done. Now we have the here. We have the 7. We have the 5. We have 6. We have 4 here. And here we have the 12, 9 and 14. If you see, all the small number came this side and all the greater number came this side. Now we have to check that size. If max heap size equal mean heap size. If both size equal, then take the pole from here, the max from here and the mean from here and do the median. Right? So in this case what you have to do, take the max heap peak, because you are just taking the number, not removing anything, to the peak plus mean heap peak divided by 2.0. This is your median, right? Yes is this case, means here is the 4, here is the 3, not equal. So in this case you have to pick from the max pole. So M is equal to max heap peak. So in this case that is not equal, take the max and 7 is the answer. If you see, the 7 is the answer, right? In this case median is the 7. This is the whole one. Let me write the pseudocode and again we will execute one more time, then we will just you have to remove this part into the code, right? So nothing more than that. Then we will go to the laptop. So we have the two methods. One add method where your element will come. Add method. So this is your compute add method, and this is your get median method. Median method already we done that. Let me add method. So what you have to do? Take the element and always put into the max heap. So max heap dot add e. First step done. Second step, add into the mean heap. Now mean heap add which one? The max element. How can take the max element from the max heap? Max heap dot pole. Second step done. This is your first step. This is your second step. Now third step. Check if mean heap size is greater than max heap size, then what you have to do? Take from the min heap, put into the max heap, right? So then max heap add min heap, not 4. So this is your whole code, and I think this is very minimized code. So far I have checked it, and that will work fine. Let me show in the laptop to how it is working there for more understanding purpose, right? So, okay, so this is the read code number 295. Same thing they have explained here. Let me write the code for that. So as you discussed, first we will take the two priority list priority queue, right? So and another priority queue we will take min heap, right? And both we have to initialize here. So min heap, by default min heap works, the priority queue by default is the min heap, right? So new, no need to do anything, but for the max heap you have to pass the argument that you want this priority queue is the max priority queue. So for that you have to take the advantage of the corrections reverse order, so it will act like the max tree, right? So as I discussed that, first we add into the max heap num, and then in min heap we will add what is the max of the max heap, right? So we do the poll, the max element will come into the min heap, right? And also we have to maintain, if min heap size is greater than the max heap size, then you have to take from the min heap and put into the max heap, right? So then you have to add into max heap from min heap poll. That's it for the adding. And the mid, as I says, that we have to return, first we have to check that if max heap size equal to min heap size. So if this is the case, then return the both, means the max heap max, we will do the peak plus min heap min peak. So take the both and divided by 2, right? Else if this is not the equal, then take from the mix heap, and that is the small answer. That much is sufficient. Let me run that. He is saying that the min heap little bit spelling mistake is here, so accepted, and just try to submit. It should be submitted also. It is the submitted, right? So this is very small code, but you should try the drive and 2-3 times for the better understanding, right? Thank you so much. If video is fine for you, then please go ahead to subscribe the channel and share the video. Thank you very much.